What's up, guys? Today we're taking a look at the Rust 1.77 release notes. As you can see from the date at the top of the blog post, this isn't exactly the most timely video. But to be honest, I usually watch a channel called Nathan Stocks for a nice summary of the release notes. But Nathan hasn't posted a video this time, so I figured I would give it a try myself. This one had a couple of really exciting changes. The first one you can see here are these C string literals. And if you've been following my channel for a while, you'll know that I'm doing a lot of projects that involve interoperation with C using the FFI. In particular, RWM uses a lot of strings. And so I've been able to use this immediately in my projects. And it's really as easy as is shown here. So Rust now supports C string literals. You just stick a C in front of a string literal, and this expands into a null byte terminated string. So you can make a C string without having to go through the actual FFI C stir or C string interface. And as the notes say, this makes it easier to write code interoperating with foreign language interfaces. And I can vouch for that. The one thing I have run into is that Rust Analyzer, I think, does not like this, and neither does the code formatter. So I've had a couple of issues with that, but otherwise, the compiler itself does use it. This one I'm not quite as familiar with, but maybe this will be handy for those of you using async functions. In this case, it says that async functions could not call themselves due to a compiler limitation. I was not aware of this compiler limitation, and I've never hit it myself, but if you're trying to write recursive async functions, you should now be able to. This means that code like this now works. If you're writing code like this, maybe you should take a look at what you're what you're doing with your life. Let's see what's next. Offset of for struct fields. This looks like another FFI thing. I haven't had a chance to use this one yet myself, but this could be useful again when you're doing FFI. And then this seems kind of nice. You can enable strip in release profiles by default. Or no, I guess it is enabled by default. Cargo profiles which do not enable debug info will enable strip by default. So I think that should basically shrink your binary sizes. So that's pretty cool. What else do we have down here? We've got some stabilized APIs, each ref and each mute. I believe these are APIs for iterating over arrays. Borrows each element, returns an array of references with the same size as self. That's pretty neat. I spent a second trying to figure out why this is different from calling iter, but I didn't realize that arrays actually have a map function defined on them. So instead of getting back an iterator that you might have to collect, you can actually get back an array. So that's pretty cool, each ref and map. And this way you don't have to copy or clone the values. And this is the same kind of thing, but for a mutable reference. The next one here, core net, is a module for networking primitives. So this seems pretty neat. Not much more to say there. I guess this is a whole new module in the core library. As you can see in a quick search, there is a standard net, which I assume existed before. So I think what this actually is an addition of a no standard networking module. So that's pretty handy if you're in a no standard environment. We've got a couple of float methods here, round ties even, offset of, I think we already saw above. Slice first chunk, let's see what this means. Return an array reference to the first n items in the slice. If the slice is not at least n in length, this will return none. So I guess this is the same kind of thing as calling chunks.next. And I think I might have actually used something like that before. So that's something to look out for in my code. And then there are some corresponding methods. First chunk mute, split first chunk last chunk mute. Those seem pretty handy, potentially. Chunk by, I'm assuming this is you give it a function to generate chunks using. Returns an iterate over the slice, producing non-overlapping runs of elements using the predicate to separate them. I can't immediately see where I would use that, but it seems interesting nonetheless. Bound map, let's take a look at this. File create new, mutex clear poison, and rwlock clear poison. Alright, what is bound map? maps a bound t to a bound u by applying a function to the contained value. I have never seen this module before. But it looks kind of cool. So for me, this is basically an introduction to the bound operator. Okay, so cool. I learned something new there today. Here we've got a new method on file. We've got create new. Yeah, this basically just creates a file if it does not exist, or returns an error if it does. So this is nice to have, in case you don't want to overwrite something, you just want to create it if it's new. I think there's an option like this for creating directories. And of course they show here where you can use the file options API. But this is pretty nice if you need to avoid overwriting a file. Next, we've got clear poison on mutex and RW lock. So I believe a mutex gets poisoned if the thread holding it panics, or something like that. So it seems like this is a way for you to recover from that panic in another thread. Yeah, this allows recovering from a poisoned state and marking that it has recovered. Very cool. I have no idea when you would use that. Whenever a thread panics while holding the mutex. Yeah. I haven't personally run into a situation like that, but if you need it, it's now there, which is pretty handy. And this is the same kind of thing on RW lock, which can be nice to use if you're going to be doing a lot of reading and not a lot of writing, for example. All right, the next thing I like to do, or that I like when Nathan does, is to look at the new Clippy lens. So the first one we've got over here is called Suspicious Open Options. And as you can see here, it checks for suspicious uses of open options create without an explicit truncate. And what they go on to describe here is that if you call open and you don't add the truncate option, that basically opens an existing file at the beginning of the file. And if you don't ask it to truncate, all of the original data stays in the file and you start writing here. So if you finish writing before you reach the end of the existing file, the data to the end of the previous file is still there. So if you're going to be calling open options new, create true, you definitely want to include truncate in almost all cases. So this is a nice new warning in Clippy. Next up, we've got option as ref cloned. And as it says, this one's pretty straightforward. It looks for .asref.clone and tells you that you should just be using .clone instead. This is something I run into occasionally because sometimes you end up just like throwing methods onto the end of something. So maybe you try to call a method on the option and then it's like, oh no, you can't move it. So you try to add clone, but really you just need it as ref. So I can definitely imagine this one popping up in some of my code. I may have accidentally done asref.clone. Now this one, again, not something I really run into. I haven't messed with ThreadLocals too much. But this one has the very short name, ThreadLocal Initializer can be made const. And it basically just tells you to try using const in the ThreadLocal macro if possible. So this explanation is telling you a little bit about what the ThreadLocal macro does. And it also so basically it's just trying to encourage you to use the const keyword if you can. It seems handy enough if you're using ThreadLocals. Next up, we got stir split at new line. This tells you to use .lines instead of hard coding the new line character. And of course, it includes the known problem of this lint cannot detect if the split is intentionally restricted to a single type of new line. In some cases, you may be looking for one of these and not the other. But in most cases, I think you will want to use .lines. Next up, we've got empty enum variants with brackets. And this one basically just checks if you have like a unit enum with brackets. It tells you to delete the brackets. Pretty handy. I don't think I've ever had empty brackets in that case, but in case you ever do, Clippy will now detect it. Here we've got another one called manual is variant and this checks for option.map unwrapper default and result.map unwrapper default, where f is a function or closure that returns the bool type. This is actually pretty cool. I didn't know about these until fairly recently. The is, sum, and. Very, very convenient. So this can save you from doing something like if let sum, if let sum, variable name equals variable name. And then inside of that, maybe you do another, if. Or if you enable the unstable option, let chains, you can actually do if let sum and. But if that's all you're doing, and you don't need the variable binding inside of the branches, this is really handy to know about. So this lint is basically checking if you do unwrap or default. I did know about this because the default boolean is false, but I always thought this was kind of like if I have to sit there and think about, oh, unwrap or default, it's a boolean, so the default is false. So I've never actually used this because I didn't like the way it looked. But if you have, Clippy will now warn you about that and point you towards these very helpful methods. Next, we've got pub underscore fields. I think this one's pretty straightforward. So this just checks if you have structs with fields declared pub, but with underscores on them. Yeah, and obviously, usually the underscore means that it's not even going to be used. So why would you have a public thing that's not used? Something like that. Next up, we got eager transmute. Now this one is actually pretty involved. Yeah, and as you'll see up at the top, this is actually a correctness lint, and it's deny by default. So I think this is like the most severe version of a Clippy lint. It'll actually throw an error if it detects it. And the reason for that is that this is checking for integer validity checks followed by a transmute that is incorrectly evaluated eagerly. So the best way to understand this, I've actually looked at this before, is by an example. So you'll see they're defining an enum called opcode, which we might see in our Venom streams if I get back to that. And the repr is U8, so each of the enum variants has an integer representation. So when they're doing this kind of conversion, they're first checking that op is less than 4, so it's in the range of the valid opcode values. Then they call then sum, which I'd also never heard of before I learned about this lint. But this takes a boolean and basically maps it to sum. But you'll notice inside of this, this is the eager transmute that they're talking about. This is actually always evaluated whether this happens or not. Another place you may have seen a similar lint is when you run, if you ever do unwrap or default, and you put a function call, or not default, unwrap or, and you put a function call in there. Usually you get a warning, I think from the compiler, or maybe from Clippy, that you're eagerly evaluating the unwrap or value. And it'll point you toward using unwrap or else instead. Because in unwrap or else, you wrap the value in a function. So unwrap or else takes a function, and the Rust can evaluate the function only in the case that you call unwrap. It's the same kind of thing going on here. This transmute happens whether or not op is less than 4. So this is very unsafe because you may actually be transmuting a number greater than 3 into an opcode, which doesn't really make any sense. Now, if we read a little bit more closely here, because when I stopped reading here, I didn't really think that it made much sense. It's like, does it really matter if you do this transmute? Because then sum should return none if this condition doesn't hold. But they go on to describe basically what I would consider a compiler bug. They said that a practical way this can go wrong is basically the compiler sees this code as this, where you do the transmute and then you do this, but the compiler knows that valid values of the opcode are less than 4, so it skips the condition. It's like, what? That seems like a compiler bug to me. Yeah. But they say, in short, it's possible for this function to be optimized in a way that makes it never return none, even if passed the value 4. So they recommend that you use lazy evaluation instead. And of course, instead of then sum, you use then. So this looks very similar to what I was saying about the unwrap or case. Next up, we've got Itter Filter is sum. And this is checking for the usage of filter option is sum. They can just be replaced with flatten. Personally, I feel like I possibly overuse flatten, but I'm glad to see that it's actually getting recommended for something like this. This is the same thing, but applied to results instead of options. Itter filter is okay. Next up, I think we have two more very similar things. We've got result filter map, and this checks for iterators using filter followed by map when you could just use flatten again. As I was saying, flatten is a very useful method on iterators, and I use it all the time. I mean, look at that. It just condenses so much. Next, we've got unconditional recursion. This is actually a pretty interesting lint, I would say. Yeah, this is a hard-to-find infinite recursion that will crash any code using it. I think I've actually done this before, so this one is quite handy. You don't think, right, equals equals just feels like a primitive, but all equals equals does is call partial EQ EQ. So this is actually an infinite recursion. So this is a great new lint to warn you about. Hopefully stop you from writing an infinite loop where you absolutely don't expect it. Alright, I think those are all the changes in Clippy. I hope you guys enjoyed this video. Let me know down below what your favorite new change is in Rust 1.77. Of course, I think I'm on 178 or 179, whatever's on Nightly right now. So let me know down below if you use stable. I'm always on Nightly, but so I don't usually get too excited about the stable releases, but yeah. Anyway, let me know what version of Rust you use, what you're excited about, what you like in Nightly, and I'll see you guys in the next video. Goodbye.